So the last time I saw you, we were talking about supplementary angles, uh, a little bit about how to kind of count measurements around the circle when we were talking about radians instead of degrees and quadrants. And then we went into complementary and supplementary angles. And the complementary ones are the ones that add up to 90 degrees, and the supplementary ones were the ones that added up to 180. And we were talking about how to find those in terms of a circle, right? Um, and we also talked about coterminal angles and things like that. And it was all pretty formulaic, right? We just had formulas that showed you how to find the coterminal angle, and we had a formula for how to find the complementary and how to find the supplementary, right? Today we're going to talk about converting between radian and degree measure, because a lot of the time what we're dealing with in terms of trigonometry is radians, because circles and arcs are measured in radians more often than not. So today we're going to talk about how to convert. If you're given a degree, how to convert it to a radian. If you're given a radian, how to convert it to a degree. And it's really pretty simple stuff. But, like anything, it takes a little getting used to. So converting between degrees and radians. If we are going from degrees to radians, we're just going to multiply whatever you're given in degrees, your degrees, by pi radians over 180 degrees. And if you remember, the other day we talked about that 180 degrees was equal to pi radians. Remember, if 180 degrees equals pi radians. So notice that this is basically the same as multiplying by 1. We're just changing the measurement from radians to degrees. So, for example, if I have let's do example A, 135 degrees, and I need to convert it to radians, right? We want to convert this to radians. What does it equal in radians? We're just going to take our 135 degrees. Often we'll write it as 135 degrees like this. Either way is fine. They mean the same thing, right? And we're just going to multiply that by pi radians over 180 degrees. And what you'll notice is automatically we can cancel those degrees, right? And what we're going to be left with is 135 pi radians over 180, right? We no longer have a thing on that. The radians just apply. And then we can just reduce our fraction. Now, each of these are divisible by 5 right off the bat. So I could go, okay, that's 27 over 36. So we've got 27 pi over 36. Each of those are divisible by 9. This is 9 times 3. So I would say that will be 3 pi over 4. What are we measuring it in? We're measuring in radians. So 135 degrees equals 3 pi over 4 radians. And now that's how we can start working with that in terms of the unit circle and trig, because we want pi more often than not when we're dealing in circles. Um, what if I have something bigger, like 540 degrees, right? That's bigger than a circle, right? It's like 360 degrees and then it kind of goes around more. The cool thing about a circle is that like this is our 0 degrees, this is 90, this is 180, this is 270, and if we take it all the way around, this is also 360, right? So if I have something like 380 degrees, it's saying that we've gone all the way around this circle plus about 20 degrees more, right? It's going to end about right here. So 20 degrees and 380 degrees are exactly the same, right? They're going to end in the same spot because a circle is a ring. It's kind of like a clock, right? You can just keep going around and around. You're never going to have more than 12 hours marked out, but each time it changes. Like you 1 o'clock, 2 o'clock, 3 o'clock, right? Rock. 1 o'clock, 2 o'clock, 3 o'clock. So if I have something like, say, 540 degrees, think about that. That's 360. 540 minus 360. I don't even know what that equals off the top of my head, like 180. So it's probably going to take us all the way like right back here or something like that, if I'm right. So it'd be like we went all the way around the circle and then halfway around the circle. Does that make sense? It's still going to stop in a similar spot, so those would be equivalent angles. But that's irrelevant kind of to converting it from degrees to radians, because we're still going to use the same formula. We're going to multiply our 540 degrees times pi radians over over 180 degrees. And so our degrees will cancel out and we will be left with 540 pi over 180, right? And this is all radians. And then we can reduce that fraction. Well, the good thing about reducing a fraction with zeros on the end is those zeros just cancel. And right now we've got 54 pi over 18. And now these are both divisible by 2. So, oops, sorry, on here. What is that? So that's going to be 227 pi over 9. 27 divided by 9 is just 3, so we're just going to have 3 pi radians. So in terms of radians now, we just have 3 pi. So like I said, it's a fairly simple conversion, right? Going from degrees to radians. You just always have to remember this formula, right? What if you were going from radians to degrees? I know you're wondering. I know you guys are super enthused to find out about this. If you are going from radians to degrees, you are going to take your pi, right? You're going to multiply your radians. Get this, by 180. degrees over pi. It's completely the opposite. So notice, whatever you're multiplying by, whatever you're trying to get rid of, is what you're going to have on the bottom. If you're multiplying times radians to get degrees, you want radians on the bottom. You want pi on the bottom so that you can cancel the radians. Here, when you're multiplying by degrees and you want to get to radians, make sure that your degrees is on the bottom so that you can cancel the degrees. Does that make some sense? Someone type something, make me feel like I'm not talking to myself. Thank you. Thank you. I know I'm putting myself to sleep a little bit, So what if I have negative pi Loki? What if I have negative pi over 2 radians? If I want to convert it to degrees, right? We want to go 2 degrees. We're going to go negative pi over 2 rad, super rad, times 180 degrees over pi radians. And what happens here is our radians cancel. And we wind up with negative 180 pi over 2 pi, right? I wrote 25. I meant 2 pi. And what's that going to equal? Well, 180 divided by 2 is 90. And since it's negative, it's going to be negative 90. Is it going to be our pi's cancel? And it's going to be negative 90 degrees. You can also write that as negative 90 degrees, right? Do you see where the pi's cancel? Just remove the I. Oh, you meant hello. I don't have a problem with Loki though. I am a bit of a Marvel fan. I think it's just another way of saying it's low key. Right? Let's do another one of those. What if I just have 2 radians, no pi, right? Not 2 pi radians, but I have 2 radians. It's going to work the same way, right? If we want to move that 2 degrees, we're just going to multiply 2 rad by 180 degrees over pi radians. And we will be left with 360 degrees over pi. And if you plug that into a calculator, if you leave it like this, it's fine. If you plug it into a calculator, you're going to get about, I should make the squiggly lines, right? Because that means approximately 114.59 degrees.
Hi.
Hi.
I'm back now.
Who are you? Oh, Meryl. How you doing?
My dog is I like that one.
So I'm in a class right now.
I'm sorry. I'm going.
See you later. That's all on video. Does anybody need any more info in terms of converting degrees and radians? You guys feel good on degrees and radians before I move on? I want to make sure you kind of get it. It's fairly simple, but got it?
So just to clarify, to turn degrees into radians, you just divide until it's completely simplified?
Well, I mean, first you multiply by, right? If you want to turn degrees to radians, you have to multiply whatever your degrees are by pi over 180, right?
Oh,
That's your first step, right? You have to multiply whatever degrees you have by pi over 180. And then you just simplify your fraction until you get to the lowest fraction you can get. Right? If you're going radians to degrees, instead you're multiplying times 180 over pi.
okay.
I mean, it's the same as multiplying by 1 because 180 degrees is equal to pi radians. So it's like you're not changing the value, right? You're just changing the unit, right? Between
Yeah.
degrees and radians. So that is a very important stipulation, right? To make sure you do that multiplication first, because otherwise you don't have a fraction.
Thank you.
You're welcome. Any other questions pertaining to that? All right, if not, we're going to move on to finding arc length. So we're moving into word problems here a little bit. Not really word problems, but application problems, right? But they're still pretty formulaic. So when we're talking about arc length, I thought I hit the purple pen, but I was writing with the eraser. When we're talking about arc length, let's talk about what it is first. We'll get into the formal part. For a circle, radius r, right? So if a circle has a radius of r, which is what we usually label the radius, a central angle theta, and we'll draw pictures here in a second and explain it. Central angle of theta, right? It's just a measurement. It's just a term for measuring angles, right? We use Greek letters. Central angle theta intercepts an arc length and arc of length S given by S, our arc length, equals the radius times theta, right? So if I have a circle, that's a pretty good circle. I had to go mess it up. Let's leave that out of it, right? And say we've got a central angle, right? We've got, say, something that goes from here to here. This would be our radius, right? Our radius is anything that goes from the center to the end of the circle. So this is the length of our radius, right? This would also be the length of our radius, correct? This is S. This is that S that they're talking about. This in here is our central angle, our theta. We could be measuring this, in which case this would be our arc length, right? And this right here would be our central angle. But more often than not, we're dealing with the smaller angle than the bigger one. But it could go either way. So what it's saying is that we're just measuring this length based on the radius. We're saying if we multiply the radius times the measure of the angle, we will get the arc length. Does that make some sense? Will we put it into play? Yeah, we will. We have to remember, though, that this is true where r, let's make that legible, where r, our radius, is measured in radians. That means if they give us degrees, we have to convert it to radians, right? And are they going to give us degrees? Absolutely, because they're not going to make it easy on you. If r is equal to 1, then our s is equal to theta. So if the length of our radius is 1, our arc length is whatever our angle is. Does that make some sense? Because then it's a radian, which we talked about when we talked about what radians actually are. So let's look at some examples here. Let's look at an example in a different color so we can differentiate between the explanation and the example. Let's say if we have a circle. If a circle has a radius of 4 inches, find the arc length. Man, I can't write today. Find the arc length intercepted by the central angle of 240 degrees. No, 240 degrees. Like, I wrote down 2 of these problems and I was looking at the bottom one. So what is that saying? We're saying 240 degrees. Okay, here I've got my circle. Right? We know that this is 90 degrees, this is 180 degrees, this is 270. So it's going to be like somewhere in here, right? So we're basically measuring the circle from the arc length from here to here, right? Starts here, goes in this direction, stops right here, right? So this is the angle that we're measuring, right? This is our theta in here. This line I just drew would be our S. Now our radius is just this, right? So what are we looking at? We're looking at some like weird Pac-Man like circle, right? Kind of goes to about right here, saying, pretend this is the center. This is the ugliest like half circle thing I've ever drawn, right? But this inside here is our theta, right? Our angle is this measure, right? This line itself is our S. This line is our R. But it's given us all that information. This is just to give you kind of a visual of what we're looking at. But what we have to do first is we have to convert this 240 degrees to radians. So we're going to have to go 240 times pi radians over 180 degrees, right? Because it's going to cancel our degrees and we're going to be left with 240 pi over 180, right? This is all in radians. Then we have to reduce our fraction, but it's an easy reduction because, well, we've got 240 over 180, which can be easily reduced to 24 pi over 18. And then that gets pretty easy to reduce because each of those are divisible by 6. So I wind up with 4 pi over 3, right? Now we're going to use that in this formula, right? This formula of S equals R times theta, right? Our formula is S equals R times theta. And S right now is what we're trying to figure out. We're trying to figure out what this arc length is. And we know what our theta is. Our theta is 4 pi over 3, right? Because that's our central angle. And our central angle is our theta. So we know that, and we know that our radius is 4 inches. So all we have to do now is multiply 4 times 4 pi over 3. And we wind up with 16 pi over 3 radians. Can you convert that? It's actually inches now, right? Because we're multiplying it by 4 inches. Can you convert that into to a decimal? Yeah, you could. You could just pop this in the calculator and you'll get approximately 16.76 inches. Man, I cannot spell to save my life today. This is going to be a terrible video. We had Meryl come in. I can't spell or write today. Did that make a little bit of sense? I'll show you another example just to make sure that you guys are getting it, but hopefully a little cleaner example this time. Star, how do you feel about this? I shouldn't ask Star because Star is paying attention. I should ask someone I haven't heard from. Aaliyah, are you getting it? You're a good student. I know that you'd be a good judge of this one. Yeah? Okay. Let me do one more so that you have another example of the same thing. Say we have a radius of 27 inches. That's long. It's a big circle. We want to find the arc length. Sorry. Intercepted by the angle. Intercepted by the central angle of 160 degrees. So we're given everything we need, but we need to put it in terms of radians, right? We're looking for S. We don't know what that is. We're given our radius is 27. And right now we're given our theta, but we're given it in degrees and we need to find it in radians, right? So the first thing we're going to do is we're going to convert our 160 degrees into radians. Which allows us to cross out the degrees entirely, right? And we're left with 160 pi radians over 180, right? Which is the same as saying 16 pi over 18. And then we can reduce that to 8 pi over 9 radians. Did everyone follow that conversion? Is just making the fractions smaller and smaller till I got to one I couldn't break down anymore. So now our theta, our central angle, is still 180 degrees, but we're referring to it as 8 pi over 9 radians. And so now we can just do the formula, right? We know that S equals R times theta, and we know what R is, and we know what theta is. So we can just measure, multiply now, 27 times 8 pi over 9, and we will get whatever the calculator tells us we get, which is about 75.4 inches. Makes some sense? The formula itself is easy as long as you know what pieces to find, right? The central angle, that's our theta. Radius, R. And what we're looking for is the S. What if we were given the arc length and the measurement and we were asked to find the radius? Could we do that? Right? What if I was given that I have a theta of 8 pi over 9 and an arc length of 75.4? Could I find the radius? We could, right? Because we know that S equals R times theta. So if I am looking for R, right, if that's what my question is, all I have to do is divide both sides by theta, right? And I wind up with S over theta equals R. So all I would have to do is take this and divide it by our angle, and we can find our radius. You should be able to find any version of a formula, right? By solving for that letter in the formula, right? By isolating that variable, it should give you the equation to any other formula. That is as far as I'm going to take it today. I am not going to jump into angular speeds like I wanted to because I feel like you guys would riot. So I'm going to stop the video there and then ask any questions that you guys might have.